Okay, so we're going to be able to find the slope when we don't even graph anything. Okay, we don't even have to use a graph. We're going to use a formula to find the slope. So last week we talked about finding slope on a graph, and when we're finding slope on a graph, if you remember, our numerator was the change in y, on the y-axis, up and down, right? How many we went up, that was positive, or if we went down, how many we went down, and it was negative. So change in y, that is called the rise. And our denominator was the change in x. And the x-axis is going from left to right. So the second thing we did was once we counted up or we counted down, then we counted over to the right, okay? And that would be considered the run. So slope is a lot of times referred to as rise over run. The change in y over the change in x. And if we're talking about change, the way that we can find the change in a number, that's like finding the difference in a number, okay? So we're going to be subtracting to find the y change and subtracting to find the x change. Now the abbreviation for slope doesn't make much sense, but the abbreviation for slope is m. Okay? I don't know, I didn't make it up. So the abbreviation for slope is m, and the formula is, on top we're going to do y2 minus y1. Notice those are not exponents, those are like, they're smaller numbers, but they're kind of underneath it a little bit instead of up top like an exponent is. Over x2 minus x1. Okay, so this is an important formula that you'll see quite a bit, actually. And you use this when you're given 2 points. So when you have coordinates, you have the x coordinate and the y coordinate, correct? Like an ordered pair. So if we have 2 of those, okay, the way that we tell them apart is that one of them is x1 and y1, and the other one is x2 and y2. That's just kind of how we tell the difference in those 2 points. Alright, so let's say we want to find the slope of 3, 5, and 7, 2. 3, 5, and 7, 2. Now we could get graph paper, and we could put those 2 points on the graph paper, draw a line in between them, and then find the slope that way. But again, the other way to do this without using a graph is to use the formula that we just wrote. So the first thing that I think is very helpful for people is to label these points. So let's label the first one x1 and y1. And let's label the second one x2 and y2. That's going to make it easier for us to not make mistakes on where we're putting things. And I know that you have just right above you in the notes the formula, but since mine is on the other page, I'm going to write my formula again. Oops. y2 minus y1 over x2 minus x1. The biggest mistake that people make is that they put the x's on top. So please do not make that mistake. Remember, the top is the rise, the change in the vertical axis, which is the y-axis. So your y values have to be on top. And our y values are the 5 and the 2. So y2 is 2, y1 is 5. So we're doing 2 minus 5, which is negative 3. What's wrong? And on the bottom, we have our x values. So our x values are 3 and 7. So our x2 is the 7, and our x1 is the 3. So we're doing 7 minus 3, which is 4. So when I'm writing my slope, my numerator is a negative 3, and my denominator is a 4. Now we talked last week about how to simplify slope. We said that slope could be improper. We said that slope should only have one negative sign, if necessary. You shouldn't have two negative signs anywhere, because two negatives make a positive. Two negatives make a positive. So since we only have one negative, then it stays just one negative. Okay? We can't reduce this any. We can't divide 3 and 4 by anything. So we're leaving it just like this. That is the slope, negative 3/4. So again, if we were to put these 2 points on a graph and find the slope of a line on the graph, we would have gotten negative 3/4. We would have gone down 3 and right 4. All right, so let's do this with some a little bit harder numbers, okay? But same process. So again, I recommend the first thing that you do, it's not mandatory, but I recommend labeling them x1 and y1, x2, y2. That's going to keep you from getting as confused. When you set up your problem, remember that you're always going to be subtracting, so sometimes that gets confusing for people too. So our y values are going to go on top, y minus y. Our x values are going to go on the bottom, x minus x. Okay? So again, our y values, we want y2 minus y1. So again, y2 minus y1. On the bottom, we want our x's. We want x2 minus x1. Do you see how maybe some people could make a mistake here with this right here? So if we're saying x2 minus x1, we need that minus sign there. Now it's a negative 2, so now we have two negative signs next to each other. Well, we'll take care of that in a second. So let's focus just on our numerator, a negative 8 minus 5. Some of you can do that in your head, no problem. Others of you are still struggling a little bit with your integers. So remember, you can use your calculator. So if you need to, put negative 8 minus 5 in your calculator. But if you don't need to, what is it? Negative 13. And on bottom, again, if you struggle with integers, just put it into your calculator. 6 minus negative 2. Remember, the negative symbol is the one next to the decimal point on your calculator. But this turns into a minus, a negative turns into a plus. So that turns into 6 plus 2, which is positive 8. So now I think, can I simplify this at all? I see that it's improper, but I couldn't make it into a whole number. It would be a mixed number. I don't want a mixed number. There's only one negative sign, so that's okay. I can't reduce it any, so this is it, negative 13 over 8. You ready to try one of these on your own? Okay, we'll give you one to try on your own. Sorry? No? That's a minus sign. So that does it make negative 8 minus 5. Because when you're thinking about your rules, you can think of this as being that negative sign over there. A negative 8 plus a negative 5. Well, maybe I should have. Please try this one on your own. Please try this one on your own. Alright, so I have the colors up here in an attempt to make it a little bit easier to visualize where things go. Remember, our y values go on top. That's our second number in each of those ordered pairs. And that we want y2, which is negative 3, minus y1, which is negative 1. So you could also see that I set up my problem with that minus sign in there so that I didn't forget to put my minus sign. Because that's another mistake that people make. So down on bottom, I have my x values, my first values. So I have a negative 4 minus a 5. And now I'm either going to do this mentally or I'm going to use my calculator depending on how I am with integers. So this would be like negative 3 plus 1, which is negative 2. And down here, this would be negative 4 minus 5, which is negative 9. But I have two negatives, and I know that two negatives make a positive, so this would be a positive 2 over 9. Final answer. So if you did not get that right, look to see where you made your mistake. Did you put all the numbers in their correct spot? And once you've checked to see if you've put the numbers in the correct spot, did you make sure that right here that you didn't just have one of those symbols? So we have minus a negative 1, not just minus 1. And then lastly, if you have everything set up correctly, making sure that you solve it, you do your computation part correctly. No one should mess up on the computation part when you're allowed to use a calculator. Some of you are trying to maybe do this in your head, and I'm telling you that I do not recommend you just doing it in your head. I think eventually you'll be able to do it in your head, but we're not there yet. Okay? Do you want to do another one together, or do you understand the process is just practicing? Okay.